Hello everyone, my name is Megha Gupta and I am Assistant Professor in CSE Department at Ajay Kumar Garg Engineering College, Ghaziabad. So today's my lecture is on propositional logic and discrete structure and theory of logic. So today I'll share some table of contents here, that is propositions, propositional variables, compound statements, basic logic operations, derived connectors, conditional and biconditional statements, principle of duality, equality of propositions, tautology, contradiction. That's it. So start from the word. What is basically is proposition? So proposition or a statement or logical statement is a declarative sentence which is either true or false. Means a statement by which we are getting the answer in true or false value. That statement is known as proposition in discrete mathematics. For example, here the following statements are given here, like Jawaharlal Nehru is the first Prime Minister of India. So is it a true statement or false statement? The answer should be true. So this is a statement which follows the proposition, right? Second is as it is true, right? The second statement is it rained yesterday. As all we know that it's not rained yesterday, right? So it's a false statement and we will have the output as a false. So we can say that this is a proposition statement, right? The third one is if x is an integer, then x square is a positive integer. Yeah, it's truth. If I take x as 9, then x square will be the 81, right? And if I take x is a -2, then x square will be 4. So x square is always positive in nature. So it will give true always. So this is also a proposition statement. Now come to the example 2. There are some statement givens which are not proposition, as please report at 9 AM sharp. So it is not compulsory that the answer should be in true or false manner. What's your name? Your name will be not in true or false value, and x square equal to 13. It's not basically in true or false value. So these are some given examples which define the proposition, what is the meaning of proposition and all. Now come to the next topic, that is your propositional variables. So basically the proposition statements are representing by the small lowercase alphabets starting from the P. So for example, we have a P statement, that is India is in Asia. Yeah, India is in Asia. It is a true statement. So this is a proposition statement which is represented by a variable P, which is known as propositional variable. And similarly 2 plus 2 equal to 4 gives true, and it is represented by a variable, that is Q. So these are the variables which are known as propositional variables. Now here we have some compound statement also. So compound statement means when we combine two propositional statements by some logical connectors or operators, right? So there are 5 basic operators or connectors we are using for compound statements in proposition statements. So these are some symbols for the following. This is the symbol which is used for the not connectivity, and this the name of this is negation. And second symbol is used for the and connectivity, which is basically known as in conjunction in discrete. And this is the third symbol which is used for or connectivity, and this is known as disjunction. And now we have arrow sign, which is basically used for if then rule. If then means implication. Implication means conditional statements. Now we have bidirectional arrow, which is used for if and only if conditions, which is also known as biconditional statements or equivalence statements. So these are some compound statements theory and some logic connectors which we'll discuss in next slides. So first basic logical operation is negation, right? So the sign for negation we used is this sign, and it means, as we all know, that not of anything means not of 0 is 1 and 1 not of 1 is 0. So this represent the negation, means opposite of the original statement. If P is a statement which is propositional statement, then not of P is this, and it is represented by this, and it is read as it is not the case of P. So if P is true, then P naught is false, and vice versa, right? If we have true value in P, then the not of P is false, and if we have false value in P, then the not of P is true, and it is represented by not of P. And here I take an example that if statement P is Paris is in France, then what will be the not of P? Paris is not in France. This is a basic logic operation that is known as negation. Second logic operation is conjunction. Conjunction basically it means ending of two statements. Conjunction represent the and statement. And statement, for example, like if P and Q both are true, only in this case the result will be true, otherwise the result will be false. If I get any false statement out of two statements, then the result will be false in case of conjunction. And it is work as in given table, like if both values are true, then the output will be true. Otherwise, if I get one false in any input, then the output is always false in nature. This is the basic operation that is known as conjunction. After that, we are discussing that is disjunction. So disjunction basically we are doing by ORing the two statements. When we have the relationship between two statements, like I have a relationship between two statements with or word, then this statement these statements are come under disjunction. And whenever the value of any one statement from the given compound statement is true, then the output will be true. Means if we are getting a single statement which is true in nature and we are combining any other statement with that statement, then always we are getting the true value. Like it is work like this: 1 plus 0 is always equal to 1. So 1 represent here the true value. So we are getting both true in case the result will be true. If we have only one true, then also result will true in both the cases. But if we have both values as false value, then the output is false. So this is the basic disjunction operation which we are used. Now let's come with the implication, that is the fourth operation, basically operation or the logic. It basically represent the if then relationship between the statements, and it is basically implication rule, and it is represented by this. So what is implication? Basically the implication is if P then Q. If P then Q means if P is true, then Q should be true. This is the implication rule. So by understand this by table. If P is true, so how many conditions are true in P? There are two conditions which are true in P. So according to this condition, if P is true, then Q should be true. So Q is true in first case, so the output will be the true. But in second case, as you see here, that if P is true, then Q is not true, so that's why the result will be false here. But in third condition, P is false. Here P is not true, so there is no constraint that the output will be false. No, if P is true, then Q will be true or false. This is not matter in implication, so the output is automatically true because the P is false in both the cases. Here we use the true value. This is not a false value, this is a true answer. So in implication, I have false in only one case, whenever P is true and respective Q is false. That in that case only we get false as in output. Now come to the fifth, that is the biconditional statements. Means this biconditional statements basically represent if and only if relationship. If and only if relationship means if both the values are same, then the output will be true. Means if both values are true or the false. That in that case only we get true as an output, otherwise we get false as an output. So this is a basic example which we are used here. Like let P, Ravi is rich. We get a statement P, that is Ravi is rich, and Q is Ram is happy. So the following statement represent the following statement in symbolic form. So basically the first statement is Ram is poor but happy. Ram is poor but happy. Here I use Ravi, in place of Ravi we used Ram, right? So Ram is rich and Ram is happy. So first statement is Ram is poor but happy. Ram is poor means not of P, and Ram is happy means Q. And here we represent the but. But means poor है but happy भी है. तो आपको and relationship show करना होगा. So not of P means this Ram is poor, and Q means Ram is happy. So this is a example for compound statement representation. Ravi is neither rich nor happy. Now in place of Ram we are using Ravi here. And here also we are using Ravi in place of Ram. So Ravi is neither rich nor happy. Ravi is not happy and neither. So both we use negation with both the statements and represent the and statement here. This is a basic example in which we are using symbolic representation of the given statements. Now we have some derived connectors also by which the statements are connected. So basically the derived connectors are NAND, NOR, XOR, etc. So let's come to the first operator, that is your NAND operation. NAND means NAND, which is a combination of and not. So basically we basically doing AND operation. By doing the AND operation we are we are doing the NOT operation on that, right? By getting the NAND AND output, we are doing the negation for that. Then we will get the output of NAND operation, right? And it is represented by this symbol here. So P NAND Q is basically in case of AND gate. In case of AND gate, we will get true whenever the both values will be true only, right? But here if I go for AND operation here, then the output will be true, false, 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 right? So in case of NAND, basically we are doing what? Not of this, not of this, right? Not of this is NAND. NAND means true, false, true become false, false become true. So this will be the NAND operation in this case. Now come to the second operation, that is the NOR operation, and it is also known as joint Daniel. So basically here we are doing that or with the NOT, means we are doing first ORing of P or Q, like true, true, true and false. This is the OR operation. But for respective OR, we are doing NOT of OR, which represent basically NOR, right? So NOR of both this two is true become false and false become true. So how I will get the table for NOR? XOR, basically XOR is basically XORing is the P and Q is true if P is true and Q is true, but not both vice versa, right? And it is represented here, right? This. So XORing basically the NOT of biconditional, means if we are having same input, at that time we are having false output, otherwise we are having true output. So show that this is equivalent to this. Basically this type of questions are come under your exams sometimes. So show that here XOR of P or Q or NOR of this is equivalent to NAND of this, right? So here if I doing P and Q XORing, if here we have two variables only, so we have four inputs. P or Q, P XOR, basically this represent XOR, right? XOR means we having if we are having both same values as an input, then the output will be false, right? So this is the XOR output. After that we are doing this operation, that is your NOR operation, right? So NOR operation basically or not, right? और में आपके starting के 3 values true होते हैं, but not of or में these will all become false, right? Now we are doing ORing of these two outputs. So false false is false, otherwise the values will be true in all cases. So and NAND table, what will be the table for NAND? In NAND we basically having true equal to false, otherwise we are getting true in all case. So these two are equivalent in nature. So how we are solving these type of questions using truth table. Now come to the next statements, that is conditional biconditional statements. As I already told you that conditional statements is if and then statement. If P then Q means if P is true then Q is always should be true, and if it is not true then the output will be false, right? Otherwise it is always true. In implication, P is called the hypothesis or antecedent and Q is called the conclusion, right? If I represent that P implies Q like this, so P is the hypothesis statement and Q is the conclusion in this case. So this is the table of the given statements, and these are some conditional statements. If A equal to B and B equal to C, then A equal to C, right? If then relationship, they are showing if and then relationship. If I get money, then I will purchase a computer. Like here, for example, here this statement is P and this statement is Q. So then this is overall statement is represented by P implies Q. If I get money, then I will purchase a computer. Now come to the biconditional statements, which I already told you that in case of biconditional statements, if we are having both the values same as in input, then the output will be true, otherwise we are getting false as in output. For example, two lines are parallel if and only if they have the same slope. Like this is the P statement, this is the Q statement. So this is represented by this P biconditional Q. You will pass the exam if and only if you will work hard. These are some examples for biconditional statements, and we are doing some variations in conditional statements. Let's start with contrapositive, then forward to converse, and at last we are having inverse, right? So in conditional statements we are having some contrapositive values, like if we are having that P implies Q as in normal statements, conditional statement, then the contrapositive is given by not of Q implies not of P. Like if I work hard, then I will pass in exam. If I work hard, then I will pass exam, right? This is a statement which represent here, this statement is P and this statement is Q. So the contrapositive statement for the given statement is not of Q, means I will not pass exam. If I will not pass exam, then I am not worked hard. This is a contrapositive statement in this case. What about converse? Converse is basically Q implies P, means if I pass exam, then I work hard. Basically this is the converse statement. And what will be the inverse? Inverse means not of P implies not of Q, means if I'm not worked hard, then I will not pass the exam. So these are some variations which are doing in conditional statements as contrapositive, converse and inverse. So here we have an example in which we have to show that P implies Q and its contrapositive are logically equivalent. So here, first of all, you have to find the P implies Q by this process, and we are getting not of P and not of Q here, by which we are getting the contrapositive relationship in between the two, and we are getting the table as this, as not of Q implies not of P, means if this is true, then this should be true, but in this case this is only false statement, otherwise we are getting true statement. So in this example, as you are seeing that both the outputs are equivalent to each other, so we can say that the contrapositive of any P implies Q statement is always equivalent to P implies Q, right? Yes. This is the next example. In this, we have to show that Q implies P and not of P implies not of Q is not equivalent to P implies Q. So here also we find P implies Q, Q implies P and this. So here you are seeing that Q implies P is not equivalent to these two, right? So this is a basic example where we have to show that. Now next to the come to the next question, that is prove that P biconditional Q is equivalent to P implies Q and Q implies P. So biconditional table is seeing like this, but in case of P implies Q, we are having this output, and Q implies P, we have having this output. And by doing AND of these two, true is true, otherwise we are getting false here and true here. So these two tables are equivalent to each other. So this is proved by using the truth table. Now next topic is principle of duality. Basically duality we are discussing in unit 3 also, that we are replacing the AND by OR and OR by AND, basically true by false and false by true. The two connectives AND and OR are called the dual of each other, right? And NAND and NOR are also called the dual of each other. Okay? So this is the principle of duality. Now come to the next topic, that is equivalence of propositions. Equivalence, as we all see some questions on equivalence, means two propositions are said to be logically equivalent, means they have exactly the same truth values under all the circumstances. So this is the question. Consider the following propositions. Are they equivalent? You have to show that these both having the same truth values, right? So here I have find not of P or not of Q, not of P and not of Q by getting this OR, we having these values, but in case of AND we having this value, and by doing the not of this AND we are having this value. So these two values are equivalent to each other, as I get false, true, true, true. So we can say that they are equivalent in nature. Now the basic next operation is tautology. So whenever the output or in the truth table conclusion output will be the true in all the cases, then we can say that this follows a tautology, means under all circumstances the value should be true in nature, right? So here we use an example, that is prove that this is become a tautology in this case. So by calculating these all, we are getting all the values which is true in nature. So we can say if all the outputs are become true, then we can say that this follows the tautology. And what will be the contradiction? Contradiction is basically when all the values are becoming false in the output, then we are saying that this follows contradiction. Here show that this becomes a contradiction if we are having P as true false, then not of P is false true, and we are doing not on these two values. True false is false and false true is also false, and the output, all the outputs are false, so we can say that this follows contradiction. And one thing is contingency. Contingency is basically the merging of true and false output. Like we are getting some output as this, false, true, true, false. Whenever we getting the output as false and true in the output table, then we can say that this follows the contingency. And if we are getting true all the values, then we are saying that this is follows tautology. And if we are getting false in all the conditions, then we are saying that this follows contradiction. So these are some basics of basically propositional logic. So this all about that's all about today's presentation, and thank you so much for